Okay, this is a tree diagram exam question. It's not a real hard one, but the ideas will help you with any tree diagram question that you might get. But it's a real exam question. It was given in the exam, grade 11 exam. So let's try it. Here's the question. Consider 3 consecutive cricket matches. Use a tree diagram to determine the probability that the captain will win the toss every time. Okay, so he tosses a coin, and it's either heads or tails. And I guess the captain has to choose what does he want, heads or tails. So let's say if the captain flips a head, that's a win. Okay. The second question is determine the probability the captain will win the toss at least once. Okay, that's a different thing, but okay. Let's figure out the probability the captain will win the toss every single time. 3, so there's 3 consecutive cricket matches. That's 3 tosses. But this is the way you build a tree diagram. Think of the first toss and think of the things that can happen. Well, when you flip a coin, there are 2 things that can happen. You either get a head or a tail. And if it's a fair coin, there's 1 chance in 2 of it being a head and 1 chance in 2 of it being a tail. Write those probabilities right on the arrows like that, and that's how you build your tree diagram. We're going to use it a little bit later, so to figure it out. Well, if he won the first toss, say in the first game he won the first toss, there he is up here with a head. Then in the second toss, he's going to flip it again. Same thing, 1 out of 2 chance of getting a head, 1 out of 2 chance of getting a tail. If he got a tail in the first and he lost the toss in the first game, he still has a chance to win 1/2 and a chance to lose. That's tails, 1/2. Okay, well, there's the second toss. And then all you do is go to the end. You see how this is, they call it a tree because it's sort of branching out here like this. Again, if he won, there's the head where he win. That's one of the possibilities that can happen. Again, he tosses it again. It can be a head or a tail. So you've got this half going off of head, tail, head, tail. And there's your whole tree diagram drawn very nicely. Okay. Sometimes it's nice to draw the outcome. Like, what is this? This is head, head, head. This is winning every time. So this branch is the only way where he'll win every time. Well, when you flip a coin, it's called an independent event because one flip doesn't affect the other flip. And so if you want to find the probability of the thing happening 3 times in a row, all you have to do is multiply. So go 1/2 times 1/2 times 1/2, and that's your answer. The probability the captain will win the toss every time is 1 chance over 2 times 2 times 2, 1 chance in 8. Okay, well, that's it. Now, this is another thing you might want to do when you make a tree diagram. Each branch, if you go all the way down the branch, represents a different thing that can happen. A head, and then a head, or 2 heads followed by a tail, or a head, then a tail, then a head, and all the way down to 3 tails. So you're looking at all the possible outcomes here. This is a kind of a illustration of all the possible outcomes. There's 1, 2, 3, 4, 5, 6, 7, 8. Hey, 1 chance in 8 is the chance of 1 chance in 8 is the chance of getting 3 heads. Another way of looking at it. But what's the probability that the captain will win the toss at least once? There'll be at least 1 head. Well, all of these ones have at least 1 head. The only one that doesn't have 1 head is this guy here. So what's the chance that you'll get at least 1 head? Well, you've got 1, 2, 3, 4, 5, 6. There are 7 different ways you can get at least 1 head. So there's 7 chances in 8. That's the probability the captain will win the toss at least once. And so if you draw a tree diagram, maybe it's not tossing a coin. Maybe it's like raining. And like there's a 70% chance of rain here. Means a 30% chance of not raining. And so your numbers here might not be 1/2 in some other tree diagram. They might be like 0.7 times 0.7 times 0.7, and you'll get all different answers, but the principle stays the same. Okay, well, that's it for today.